Hello and welcome to Mr. Alvarez's virtual chemistry classroom. Today we're learning about parts per million. Our aim for today is, how can we express the concentration of very dilute solutions? Parts per million, or ppm for short, is a way of expressing the concentration of a very dilute solution. Just like if you were to do percent composition, that would be out of 100%, or out of 100%. ppm, parts per million, is out of 1 million. Other ways to write ppm, it can be expressed as milligrams per liter. You would use that sometimes in water. Or as milligrams per kilogram. You would use that sometimes for talking about concentration of things in soil. If we were to compare parts per million to things we see in our everyday life, 1 part per million would be very similar to 1 inch in 16 miles, or 1 minute, 60 seconds, in 2 years, or 1 penny, 1 cent, in $10,000, 1 ounce of salt in 31 tons of potato chips. And finally, a part per million would be analogous to 1 bad apple in 2,000 barrels of apples. So that kind of gives an idea of how small a part per million actually is. The formula for calculating parts per million is ppm, parts per million, equals mass of solute, the thing that gets dissolved, divided by the mass of the solution, the total solution, times 10 to the 6th, which is 1 million. 1 with 6 zeros is 1 million. Let's try the first problem together. Problem number 1 states, the solubility of AgCl, silver chloride, is 0.008 grams per 100 grams of water. What is this concentration in ppm? So the first thing we do is we write our formula. ppm equals mass of solute over mass of solution times 10 to the 6th. I plug in my numbers. ppm equals 0.008 grams over the solution, 100 grams, times 10 to the 6th. Grams and grams cancel out. Our unit will be ppm, parts per million. So ppm equals, and here I would take it one step at a time. The very first thing I would do would be to divide 0.008 divided by 100. And of course we get 0.0000, 4 zeros, 8 times 10 to the 6th. Now, I leave this number in my calculator, 0.00008, hit the times button, multiplication symbol, 10, and now I'm going to find the caret. The caret is an up arrow. That means raising a number to a certain power. Here, we're doing 10 caret 6, 10 raised to the 6th power. When I hit enter, I get my answer is 80 parts per million. Problem number 2 is a little bit trickier. Problem number 2 states, a certain pesticide has a toxic solubility of 5.0 grams per 1 kilogram of body weight. What is this solution's solubility in ppm? Before we get started, we should write our formula. ppm equals mass of solute over mass of solution times 10 to the 6th. But before we start plugging numbers in, we have a problem with our units. For our mass of solute, we have 5.0 grams. For our mass of solution, we have 1 kilogram. The units are not the same. So before we go any further, we must convert to make sure both units are the same. What I'm going to do is I'm going to take 1 kilogram and convert that to grams. 1 kilogram over 1 I look at table C of my chemistry reference tables and find out that the conversion factor for a kilo is 10 to the third. There are 10 to the third grams in 1 kilogram. Kilograms and kilograms cancel out. I'm left with 1,000 grams as my mass of solution. Now I can plug my numbers in. ppm equals 5.0 grams is our mass of solute over 1,000 grams, which is our mass of solution, times 10 to the 6th. So once again, I'm going to take this very slow. First, I'm going to put 5.0 divided by 1,000 into my calculator. I get ppm equals, grams and grams cancel out, 0.005 times 10 to the 6th. So when I punch this into my calculator, it's 0.005 times 10 caret 6. If I do that properly, I should get 5,000 ppm. Let's try one more together. Problem number 3 states, helium gas, 3.0 times 10 to the negative 4th grams, is dissolved in 200 grams of water. Express this concentration in parts per million. Well, first, let's write our formula. ppm equals mass of solute over mass of solution times 10 to the 6th. Our mass of solute is given in scientific notation. That's okay, we'll still plug in. ppm equals 3.0 times 10 to the negative 4th grams over mass of solution, 200 grams, times 10 to the 6th. Grams and grams cancel out. And when I put this in my calculator, I would be very careful. So I'd start off one step at a time. So I would type in 3.0 times 10 caret negative 4. If I do that properly and I hit enter, I should get 0.0003. After that, I can now divide by 200, hit enter. If I do that, if I put 0.0003 divided by 200, I'm going to get a very small number of 0.5 zeros, 1 5. I'm almost done. I multiply that by 10 caret 6 times 10 caret 6, and I get an answer of 1.5 ppm. I know what you're thinking. When am I ever going to use this? Well, if you remember a few years back, Flint, Michigan had a problem with lead concentration in their drinking water. Actually, all these numbers you see here are in parts per billion. The formula for parts per billion with a B is similar to the one we just used. However, when you would divide mass of solute divided by mass of solution, you would instead multiply by 10 to the 9th, which is 1 billion. So you see on this chart, Detroit showed that there is a lead concentration of 2.3 parts per billion in their drinking water. The EPA, the Environmental Protection Agency, says that there is a cause for concern when the lead concentration levels reach 5 parts per billion in the drinking water. The water from the Flint River, tested in 271 homes, showed a lead concentration level of 27 parts per billion, over 5 times the level that the EPA says there's a cause for concern. A Virginia Tech study showed that in the 8th Ward, the highest recorded levels of lead concentration in the water was 158 parts per billion. If I was to convert that into parts per million, ppm, that would be 0.158 ppm. And finally, the highest recorded level by the Virginia Tech study, a wider Virginia Tech study, showed that there was a lead concentration of 13,000 parts per billion in the drinking water. Now, the EPA also says that water is considered toxic waste above 5,000 parts per billion. So if I'm going to convert that to parts per million, which we learned today, the toxic waste level is 5 ppm, and the water tested in Flint, Michigan showed 13 ppm of lead concentration in the water. Thank you for joining Mr. Alvarez's virtual chemistry lesson. Today we learned about how to calculate parts per million, or ppm. I hope you learned something today. Please join us again soon.